All right, welcome everyone. In this video, what we're going to talk about is frames and machines. Previously, we were talking about trusses, and the difference between a truss and a machine is a truss really is composed only of pinned connections, or all two-force members. And that was important because when we were analyzing our truss, what we could do is we could break it apart, and we always knew the direction of the force would have to be along all the members. Now the difference between that and a frame, and a machine and a frame are kind of the same. The only difference between the two is their overall purpose, but we analyze them the exact same way. So with a frame and a machine, there's going to be at least one multi-force member. So if we were to look at this frame down here, I can see that there is a two-force member with member BE. However, member DCBA and CEF are actually both multi-force members. So, and I can break it apart. And if I were to break it apart and look at the free body diagram, I'd have a tension here, and I'd have an AY there, and an AX at A. Now, like I said, at B, because it's a two-force member, I do know the force of that member. But up here is C, I'd have some kind of CY, CX, and so on and so forth. So I won't go into it, but the point being is that now we have these members with multiple forces going on. So let's talk about how we're going to analyze these problems and then follow up with an example. The general process for these problems is a first step would be looking at the entire structure and looking at some kind of free body diagram and seeing what you can solve, if anything. So for example, this one up above, I can see that before I take it apart, I would have a tension here, and I'd have an AY, an AX, and I have my weight over there. So I have three unknowns, I have three equations in statics. I could totally solve for those reactions. That would be the first step, to solve for those three. After I do that, that's when I want to break it apart and look at a free body diagram of each one of those members. And a couple little hints is when you are looking at an individual member, you want to identify those two-force members. And remember, to identify a two-force member, it just means that it's only pinned on the two sides. There's two pins that are holding it together, and there's forces are only applied at the ends, whatever it might look like. And after we identify a two-force member, we're also going to use the fact that we know that a force on one member must equal the negative force on another member when they're connected to each other. So for example, one, I identified this two-force body, so I just drew it as an arrow. But if I were to look at the other cross member, what is that, CEF, I would have an equal and opposite FBE. I would also have an equal and opposite CY and CX. So just making sure you get all those signs straight on how it works when you break them apart. Newton's third law: for every action there's an equal and opposite reaction, all that good stuff. So after I have a free body diagram for my members, I can go through and start looking at each one of the members and say, what can I solve using my three equations of statics? So any member that has three unknowns, I can use some of the forces X, some of the forces Y, and some of the moments in order to find all the forces, and then move on to other members. So the last step I would be, second to last step would be to solve for those forces in a member, and then use that fact that we know that other members have equal and opposite. So you would repeat as needed for the other members. All right, so let's take a look at an example of what I mean. In this case, I have this goofy looking structure, and I'm trying to find all of the forces on members CEF. So if I were to start at the very beginning, I would say, well, how many unknowns do I have for the entire structure, or free body diagram for the entire structure? I'll just draw right on here. That's the easiest, right? So I have some kind of dy and a dx because I have a pin connection there. A is a roller, so I know I must have some kind of ax there. I have three equations, three unknowns. I can solve for that, so that's the first thing I want to do. So if I do some of the moments about d is equal to 0, 40-pound force times 13 in my positive direction, minus this a times 10 is equal to 0. giving me a force at A of 52 pounds. And for my sum of the forces in the x and y direction, I get a dx negative 52 and dy of 40. So after I have those three external reactions, now I need to start breaking it apart and looking at those individual members. I'm interested in CEF. So if I were just to look at member CEF, I end up with a free body diagram that looks like this. So if I count my unknowns, I have 4 unknowns. It means no matter how hard I try, I would not be able to solve for all 4 of those unknowns. So I need to move on to a different member. I'm going to have to start somewhere else. And let's take a look at ABF then. Now if I look at ABF, I also have too many unknowns. So you might say, well, this whole thing must be unsolvable. However, if I look at ABF a little more closely, because I have my FY and my BY along the same line of action, I can't solve for everything, but I could solve for my BX and or my FX. So for instance, if I were to take the sum of the moments about point B equal to 0, that gives me some kind of force in the x direction equal to 78 pounds. Unfortunately, these problems are really like this. You have to almost solve a puzzle, you know? If you hit a roadblock, you figure out what you can solve. Now, I could also solve for bx there. Obviously, it's equal to 78 in the opposite direction. But I don't really care, because once I have my f in the x direction, I mislabeled this up here. This is supposed to say fx. I now have one of these forces for CEF. So now I only have 3 unknowns there, and then I can go back up to CEF and solve for that. So I would take some of the moments about point C, where I have 2 of my unknowns, equal to 0, to solve for that guy. I have this 40, lever arm of 9, minus this 78. That's lever arm of 4. Oh, look what I did there. So you do have to be careful here. So I have 78 pointing to the right, and I found that to be, and like I said in the very beginning, if it's pointing to the right on this one, it must be pointing to the left because I have an equal and opposite reaction. So let's make that go away and that arrow go away, so at least we can represent it in the right way. So when I get to this FY is also in the negative direction. The 40 is in the positives. Yep, that's right. And I have FY times its lever arm of 4 inches being equal to 0. And from that, I get an FY equal to 12 pounds. And I got it to be positive, so it's pointing up. And from my sum of the forces in the x direction equals 0, I can get that CX is equal to 78 pounds, pointing to the right. And from my sum of the forces in the y direction equals 0, I have, don't forget that negative 40 on there, plus this 12, plus CY is equal to 0. So I end up with a CY that's equal to 28 pounds up. So FY, CX, CY, and of course I already have my FX I found to be 78 pointing to the left. So that's a kind of how these problems go. There's no real right way or process you can solve after you get into it. You're just going to have to move member by member to see what you can solve for and working on through. Hope that was helpful, and I look forward to talking to you all soon. Thanks.